Today I'll be assembling our Benchtop Pro CNC machine using our NEMA 23 plug-and-play electronics and our plug-and-play spindle system, making this machine truly ready to assemble, set up, and get cutting. Our Benchtop Pro CNC machine is designed for precision production of finished goods, equally suited to industrial, business, or home shops. When you want the ability to make parts that fit together with tight tolerances out of aluminum, wood, or plastic, this machine has the right stuff. Or parts. All this is accomplished with a stout all-metal frame and premium components such as profile linear rails and precision ball screws on all axes to deliver class-leading repeatability, stiffness, and power. Like all our machines, the Benchtop Pro features a dual drive system where both sides of the gantry are independently driven, providing ample cutting power and acceleration in all directions. The Benchtop Pro comes in 2 foot by 2 foot and 2 foot by 3 foot work area configurations. We're building the 2 foot by 2 foot machine, which means I have 25 inches by 25 inches and 7 inches of Z clearance. Fully outfitted, the Benchtop Pro 2x2 machine occupies a space that's 43 inches wide by 43 inches long and 36 inches high. And like our large format machines, the Benchtop Pro is world power ready, meaning you can order or configure the electronics for just about any local wall power standards. Now that I have that out of my system, let's build this Benchtop Pro CNC machine. I'll start by gathering the tools I'll need to build this machine. I'll be using our Pro Build Assembly toolset, which is available for purchase with your machine. By far, the most important tools in this toolset are the ball and Allen L wrenches. These work great with our anchor fasteners. Besides these basic assembly tools, our toolset also includes 2 power driver bits and an extender that allow you to use your drill driver and speed up assembly. I'll also be using my tape measure and my drill driver to speed things up. And the last thing I'll need before I start building my machine is to download the step-by-step assembly instructions from cncrouterparts.com/instructions. One of the few early decisions I need to make on this build is how high I want to install the cross members. There are 3 options: low, medium, and high. These are designed to flexibly accommodate capacity and reach requirements, as well as allow users the ability to keep the work surface flush with the side Y and slave axes. Let's face it, the less exposed machine surface to accidentally jog into, the better. The middle position is by far the most common, and works great with our included T-slot table and a 3/4 inch thick spoil or project board. The lower position is useful if you tend to machine on large objects that otherwise wouldn't fit, or are machining very deeply with specialized tooling and need the extra reach for that reason. The upper position is useful when you're not using the included T-slot table and are instead mounting a 3/4 inch spoil board directly to the cross members. I plan to use the machine with the included T-slot table and a spoil board, so I'll choose the middle cross member mounting height. As I unpack the machine, note that the axes come individually pre-assembled. This dramatically reduces final assembly time, something you and the editor of this video are sure to appreciate. With the parts unpacked, we can jump right in. The first step is to join the Y-axis and the slave axis together using the 3 pieces of heavy-duty extrusion. The anchor fasteners in the extrusion bolt directly to the tapped features in both axes. I'll fasten all 3 cross members to this axis first before moving on to the other side. This is where that drill driver with a ball nose driver bit comes in very handy. Moving on to the other side, I'll attach the cross members using the same process. The 40mm extrusion for the Z-axis cable track comes in handy to support the machine weight as I line up the extrusion fasteners with the tapped holes in the slave axis. Next, I'll add the machine feet using the feet blocks, M8 fasteners, and M8 roll-in T-nuts. The T-nuts can be rolled in, or the entire block assembly can be pre-assembled and slid in as I'm doing. The front block should be flush with the cross member extrusion, and the rear block as far back in the slot as it'll go. And in the interest of symmetry, I'll do the same on the other side. And I'll add the 4 M12 leveling feet taking care to set them at the same initial height, though I'll dial them in further when I level the machine. Finally, I'll tighten the jam nuts for now. Now that it has them, I can rotate the machine so it rests upright on its feet. Next, I'll install the gantry riser plates by first sliding in the T-nuts and roughly positioning them. The riser plate itself self-aligns with the dowels, and I'll fasten the plate using the M8 socket head fasteners. And as is becoming a pattern, I'll repeat on the other side. Using feats of strength, I'll move the X and slave axis to the rear. Just kidding, it's not that hard. I'll fetch the gantry extrusion and preload the T-nuts into the top and bottom slots of one of the long faces. These will accept the fasteners for the X-axis assembly. Now I can rotate the machine 90 degrees up. This is going to allow gravity to work for us, for a change. The gantry extrusion can now be easily fitted between the plates and fastened into place. And should we do the same on the other side? Yeah, we should do the same on the other side. With that done, I'll get the X-axis assembly ready to be mounted by first removing the rigid dust covers. From our factory, these covers are retained by only 2 fasteners each, with the remainder of the fasteners in the associated axis hardware bag. With the covers off, I can get the gantry T-nuts spread out a bit, though I'm just roughly spreading them out for now. Next, I can place the X-axis and measure from the extrusion to align it per the instruction. Using a pencil, I'm marking the T-slot below each of the fastener holes. In the odd case one of my T-nuts was already below the hole, I'll scoot it away with the pencil and mark below it, moving the interface plate as needed. Now I'll line up each of the T-nuts over the marks I've just made. And next I'll replace the axis and fasten it to the extrusion. A big shout out to Gravity and Logical Instructions for the assist. I'll rotate the machine back onto its feet, manually drive the gantry forward, and install the rigid dust covers. Likewise, for the Z-axis, I'll start by removing the rigid dust covers. On the Z-axis interface plate, I'll remove the label and any residue it left behind. I want the Z-axis to sit as flat as possible. Now I'll slide in the T-nuts, roughly lining them up so the Z-axis will be centered on the plate. Position the Z-axis and install the fasteners. The last two can be an awkward angle for power tools, so I'll use my trusty L-wrench with a ball end. And finally, I'll reinstall the rigid dust covers. My next step is to add the coupler halves to the NEMA 23 motors and fully tightening the collars. With the couplers installed, I'll fit the motors to the machine, starting with the Y-axis. Then the slave axis. I'll mount the motor on the X-axis next. And finally the Z-axis motor finds its home. I'll need a safe place for all the motor, sensor, and spindle cables, so I'll install the cable tracks, starting at the lower track. I'll mount the red cable track bracket with a 90-degree bend into the machine frame bottom T-slot using the measurement provided. And likewise for the straight cable track bracket up on the gantry. The two cable tracks are identical, so picking one, I'll identify the fixed cable track end. This is the end where the last two links are locked together, and fasten that to the bottom cable track bracket. The other end I'll fasten to the gantry bracket. Moving on to the X-axis cable track, I'll fasten the cable track extension to the Z-axis. and using the roll-in T-nuts, I'll fasten the lower fixed cable track to the upper T-slots of the gantry. And once again, referring to the instruction manual to ensure I position the fixed end of this cable track the correct distance from the edge of the gantry. And likewise, I'll fasten the other end of the cable track to the Z-axis cable track extrusion. This machine comes standard with a heavy-duty aluminum T-slot table that's installed by placing the individual T-slot sections in the desired orientation, allowing the table to either be flush with the front of the machine or overhanging the front of the machine for extra clamping area. I'll use the T-slot tabletop sections as templates and mark where the roll-in T-nuts should be placed. Removing the tabletop sections, I'll roll in the T-nuts, align them with my marks, and fasten the tabletop sections. This Benchtop Pro CNC machine is typically configured with our plug-and-play 3 horsepower spindle package, though we also have a full line of router mounts to mount just about any router or aftermarket spindle out there. I'll start by fastening the base adapter plate to the spindle body. Holding the spindle assembly to the Z-axis, I'll establish approximately how far up I want the spindle to be mounted. Generally, I find having the collet nut flush or just below the plate works well in most situations. Now I can loosely pre-assemble the fasteners and T-nuts on my tramming plate. I'll slide the base adapter plate to the reference mark and pull the plate to the left, seating the locating dowels against the edge of the T-slot, and tighten the fasteners. Organizing the fasteners from the Easy Tramming Kit, I'll be sure to find the longest M8 socket head, as this is the one that should be used with the eccentric adjustment nut. I'll partially thread the shorter M8 fasteners, then the pivot, and finally the eccentric nut. I'll use this eccentric nut later if I need to adjust the left to right tram. For now, I'll insert the centering dowel. Later I'll remove this if I need to adjust the tram left to right. We recommend labeling or color coding all the machine connections, as it makes plugging them in correctly now and in the future far more likely, and increases the odds that you'll be calling us to tell us about all the great things you've made with your machine and not troubleshooting a mismatched sensor or motor connection. That said, we're here to help. Now it's time to wire this machine up. I'll start by opening both cable tracks using a flathead screwdriver. And just like when I wash my car, I'll start from the top and work my way down. Starting at the Z-axis motor, I'll label both ends of the cable with green electrical tape. Again, following the color codes found in the assembly instructions. Next, I'll install the Z-axis home and positive limit switch. This is the only axis that homes in the positive direction, that is, with a tool homing up and away from the machine table. And I'll also label this connection with green electrical tape. Next up is the high current spindle motor cable. I'll connect the spindle motor cable by aligning the arrows and fully threading the connection. It's especially critical to leave enough slack for this so that the axis can travel its full stroke without getting the cable pulled. Then I'll gather the cables in the upper cable track and close the sections. On the right side of the X-axis, I'll install the positive limit switch. I'll use the locking nuts to secure both sides of the sensor and orient the 90-degree cable upwards towards the top of the gantry. This switch will get 2 blue stripes on each end, blue for the X-axis and 2 stripes to differentiate this positive limit sensor from the negative limit sensor on the other side. Speaking of the other side of the X-axis, the home and negative limit sensor cable will get a single blue stripe, and the same for the X-axis motor cable. Now I can gather the cables from the upper cable track and the X-axis cables together and feed them into the lower cable track, including the X-axis positive limit switch, which I'll run the cable for that along the top of the gantry over to the lower cable track. And close the segments of the lower cable track. Next, I'll install the Y-axis home sensor, measuring carefully so that I can install this and the corresponding slave axis sensor the same distance. It's important that these two sensors are installed the same amount, as it gives us a good starting place for squaring the gantry. A red stripe for this sensor tells me it's the Y-axis home and negative limit sensor. I'll install the slave axis sensor to the same depth, install the lock nut, connect the sensor cable, and label it yellow. Around the back of the machine, I'll connect a Y-axis motor cable and Y-axis positive limit sensor and label the motor connection with 1 red stripe and the sensor with 2 red stripes. Again, telling me that this is the Y-axis positive limit sensor and not the Y-axis home negative limit sensor. And finally, I'll connect the slave axis motor cable and label both ends yellow. Now I'm ready to plug all my connections into the NEMA 23 plug-and-play CNC controller. Starting with the motor cables. The green cable goes to the Z-axis, red to Y, yellow to slave, the blue motor cable goes to X, and on the sensor side of the controller, I'll connect the single blue X-axis and negative limit sensor cable to the port marked X negative, then the double blue X-axis positive limit sensor to X positive. Red Y home and negative limit sensor will go to Y negative. Double red Y positive limit sensor to Y positive. The yellow slave homing sensor will go to the sensor port marked slaved. And the green positive and home limit switch will go to the port marked Z. I'll connect the sensor cable to the E-stop switch and the other end to the port marked E-stop. I'll connect the Ethernet cable to the controller and the other end to my control computer, and the spindle VFD data cable to the SPTHC port, and the other end to our plug-and-play VFD controller. And finally, the high current spindle motor cable to the VFD controller. I'll connect the CNC controller to wall power and turn the main power entry switch to on. Verify that the motors are enabled. Start the control software. I'll clear the E-stop and click on the reset button, and finally jog the machine using the keyboard arrow keys, verifying that the machine moves in the corresponding directions. Next, I'll verify that the home sensors and the homing configuration are correct by selecting Ref All Home. When told to reference home, the machine will begin a process of driving each axis back to a known and fixed location, in this case the homing sensors. And once there, it'll zero the machine coordinates. This allows the machine to square the gantry using the Y-axis home on the left and the slave axis home sensor on the right. Referencing the machine also means that we have fixed work offsets, which is important for project jigs and when we run multiple programs that we'd like to run in the exact same spot each time. This is also useful for restarting a program that is interrupted by power loss. I'm ready to transition the machine to its permanent home on a mobile industrial cart that ADX designed and built specifically for this machine. I guess there are 2 takeaways here. 1, that this is a very rigid and therefore heavy machine. And 2, I'd be in much better shape if I built more of these. Next, I've disconnected both controllers, and I'll start installing the hanging hardware kit so that I can mount these directly on the industrial cart. I'll remove the plastic plugs and verify that I have the keyholes oriented correctly on the hanging brackets, and tighten the brackets into place. On the industrial cart, I'll position and mark where I want the first hole to go, and use a level before marking the second hole. I'm using M8 fasteners here to mount the enclosures. The larger plug-and-play controller is quite heavy, so I'll have Blake help hold it while I mark and level the mounting holes. The cool thing about ADX is the musical symphony of power drills and tools in the background. I'll reconnect all the cables, and this machine is ready for final leveling, squaring, and tramming. These and other next step topics, including spoil board creation and dust collection, are covered on our website and right here on our YouTube channel. Thanks for watching. If you have any questions about building this Benchtop Pro CNC machine or general information about any of our products, check out our website, cncrouterparts.com, or contact us today.